Today's lesson is on Hess's Law. In our last lesson, we learned how to calculate the heat of a reaction using delta H formations of our products and our reactants, and subtracting our reactants from our products. Today's lesson, you're going to learn another way of calculating the delta H of a reaction, and that's using Hess's Law. So, what is Hess's Law? It's a way to calculate the delta H of a reaction when you do not know the delta H of the reactants nor the products. You can use the heat of a reaction from other reactions that you know the delta H of to calculate the equation with an unknown delta H. In a Hess's Law problem, you will be given the following: an overall reaction with an unknown delta H, and two or more reactions with a known delta H. So this is what a Hess's Law problem will look like. So right here, this first reaction is our overall reaction. And we know that that's our overall reaction because we don't know the delta H. You see a question mark there. The three reactions that are below the delta H, the overall reaction, that have known delta H's are our steps. So now, how do we calculate the delta H of this overall reaction? Well, the first thing you want to do is in each step, you're going to find the substances that are in the overall reaction, but not in the other known steps. So in our first step, we have hydrogen gas. Well, hydrogen gas is not in our overall reaction, so that's not what one of the substances we're looking for. We have carbon monoxide. Carbon monoxide is also not in our overall reaction. We have water in the gas form. That is in our overall reaction. However, it is not. It's also in our other steps, in our other two reactions, so we don't want to use that one. So we're going to focus on this carbon right here because it's in our overall reaction and it's in our step, but it's not in any of the other steps. So we've got that one substance there, and you need a substance in each step. So carbon monoxide, still not a good substance. Water, still not a good substance. Carbon dioxide. This would qualify as a good substance because it is in this step and only this step, and it is also found here in the overall reaction. The last step, CH4, is a good substance because it's in this step and it's in our overall reaction here, but it's not in any of the other steps. So now we found a substance in each step to be concentrating on. So now we need to check to make sure that the substances that we underline match both the location or side of the reaction and coefficient of the overall reaction. So we'll start with this first step. The carbon, the substance we underline, is not on the correct side. It also does not have the correct coefficient. So we need to manipulate this step so that it shows up, so that the carbon shows up on the reactant side with a 2 in front of it. So in order to get the carbon on the reactant side, we need to reverse or flip the entire reaction. So that puts our carbon plus our H2O in our reactant side, and then we're going to then that moves H2 plus carbon monoxide onto our product side. That will also change the delta H of the reaction, because when you flip a reaction, you reverse the sign of the delta H. So that means that the delta H will become a positive 131. But unfortunately, we're not done with it yet. So the carbon has a coefficient of 1 right now, but it needs to have a coefficient of 2. In order for it to have a coefficient of 2, we need to multiply both the product side and the reactant side by 2. So we put a 2 here, a 2 here, a 2 here, and a 2 here. And when you multiply or divide by a coefficient, as we just did, you multiply or divide by that same coefficient with the delta H. So that means our delta H because we flipped the reaction, will become positive now. And it'll become, we multiply this 131.3 by 2 to give us 262.6 kilojoules. And now we are done with that first step. In our second step, we have the carbon dioxide that we're focusing on. Now, lucky for us on this one, the carbon dioxide is on the correct side of the equation because it's on the product side in both the step and the overall reaction, and it has a coefficient of 1 in both of those reactions. So we're just going to copy this reaction again. So we have CO plus H2O goes to CO2 plus H2. And because we didn't do anything to the delta H of the reaction, we are not going to do anything to the delta H here. So we just leave it as negative 41.2 kilojoules. And we're done with that one as well. In the last step, we're focusing on the CH4. The CH4 is not on the correct side of the reaction, but it does have the correct coefficient. So all we're going to do in this case is flip the reaction. So we have carbon monoxide plus 3H2 goes to H2O plus CH4. And because we flip the reaction, we need to reverse the sign, which means that this becomes a negative 87.9 kilojoules. And again, we're done with that. Now that we've gotten the substances that we underlined to match, we need to add the steps to make sure that it matches the overall reaction. And once that happens, we can then go ahead and add our delta H's. So if we add all these steps together, and we're going to combine like terms and cancel things out as we go. We have 2 carbons right now. We don't have carbons anywhere else in the reaction, so we can leave that as is, and we cross it out once we're done with it. We have 2 H2Os here, another H2O in our second step, and we have an H2O on the product side of our third step. The H2Os with the coefficient of 1 will cancel each other out, so we can just bring down the 2 H2Os then. And now we're done with that because I brought it down. We also have 2 carbon monoxides. Well, in our first step and on the product side, we have 2 carbon monoxides. So those carbon monoxides from the reactants will cancel out with the 2 carbon monoxides from the first step in the products, and we don't have to worry about them. And then the 3 H2s that we have left, well, we also have a total of 3 H2s on the product side. So the 3 H2 there, and the 2 H2s from the first step, and the 1 H2 from the second step will cancel each other out. Now, the things that are left on our product side are CO2 plus CH4. And this does match our overall reaction, which means that to find the delta H of this, all we have to do is add the delta H's of our steps. So we have 262.6 plus negative 41.2 plus negative 87.9. And when we add all those up, we should get 15.3 kilojoules. If you have any questions, please feel free to ask them, and good luck on your Hess's Law calculations.